Imagine filling your car with gas or diesel that came from sawdust or wheat straw. Sound far-fetched? Perhaps not. Professor Mahimpi and his students at the University of Calgary's Schulich School of Engineering are working on that very possibility, creating fuel oil from otherwise waste product and perhaps lessening our demands on traditional non-renewable oil and gas.
Basically what we have been trying with my groups is a bunch of PhD students, master students and postdocs. We are trying just to find different means to convert the biomass, especially waste, to useful fuels and chemicals. I have been doing this one for quite a few years, about 5-6 years ago, and we have got very successful results, and we are trying just to get less than 10 years we get to commercial stages that we can take it out and use it for different purposes. Process basically is called, we are having a combination of torrefaction, pyrolysis, and gasification. What you're going to see that in a moment is going to be pyrolysis. We call it fast pyrolysis and a slow pyrolysis, depending on how fast or slow you heat up your system. We call it reactor. So we try just to use the waste biomass, what we call it, the things that people don't use it. It's going to be, especially for us that we are living in prairie, Alberta, Saskatchewan, British Columbia, or it's not prairie, but part of it we can use the waste biomass. What is it? Is wheat straw, flax straw, oat straw, barley straw, that there is no value in a sense for it. We're trying just to use those. We are not going to go to the food level or food level biomasses, which is we are not competing with the food stream. So what would happen? We are going to just heat up with pyrolysis, heat up our reactor, and based on this, we are going to have a rapid deterioration of the bonds in a sense between like carbon, hydrogen, nitrogen, depending on what kind of biomass you have it. And when it breaks, so you're going to have different fuel, different chemicals. The fuel that we get it, we call it bio oil. Bio oil is not a good product. There is corrosive, is acidic, is low energy content, is lots of water in it. So what we call it, we are trying just to increase or enhance the properties to bring it to the level of oil that you are using, the gas that you are using in automobile. So we are gonna get there, but we are not still. There is lots of challenges that we have to answer and face. We are gonna convert the bio oil, which I'm gonna show it is a black liquid, to biofuel, which is going to be useful for our purposes. Different. So we are trying just to make like kerosene. We are going to try to get naphtha. We are going to try to use to generate petrol and different stream of the materials, chemicals. Yeah. Ultimate goal is just to make biorefineries, a small scale in our university and a bigger scale in maybe Alberta sometime. So what I mean of biorefinery, making syngas through gasification, making bio oil through pyrolysis, making biochar through torrefaction and also pyrolysis, and a variety of the useful chemicals and fuels. That's our ultimate goal, yeah. Being a professor in the university always gives me an immense pleasure just to do my work with my students and postdocs, because when I work with them, I know that there is a lot of other people who are taking advantage of this one and can take this knowledge to the society.
There are still some challenges to rise above in the years to come, but perhaps one day rail locomotives, transport trucks, and your car will run on fuel made from sawdust and grain stock. Francois Snow, HDindieNews, Calgary.